In this section, we want to see how, even if we haven't learned coding yet and have no idea how to write code, we can still use ready-made libraries and the modules within them to create a 3D model. For this, whichever version of the library you install, you'll have access to it. We want to continue our discussion and give practical examples of the modules you can use. So, as always, we create a new scene in our project. Right-click, New, CityEngine Scene, Finish. There are several libraries available that we can use. Basically, when we say library or module, we mean code. Code that has already been written, meaning others have written it and now we want to use it. We go into the Rules subfolder, and the modules we can use are actually written in CGA language. These are codes that are written exclusively in CityEngine, and you will learn this CGA language later on. But we want to see how we can use these ready-made modules in our own work. The point is, if you have a footprint, which means you have the location of the building, meaning in your scene you have this building's position. Now, whether you brought this building location from a GIS layer or you drew it yourself, if that's the case, you are allowed to use the Building from Footprint module. To use it, you just drag and drop it onto the shape you have here, and it will generate the model for you. Because the coding structure is parametric, you can change the information and parameters related to the code in the Inspector section. For example, we want to set the representation to schematic mode. We select this option, and we can easily view the schematic mode. If we want to change other information here, like the usage, we can do that as well. We want to change the type of roof or the form. For instance, set it to flat mode. It creates the flat mode for us, so we can easily control the parameters related to the code in this inspector. There are also a number of parameters here. We can also control some of the parameters from this section. For example, our grid is currently set to schematic. This is the model we have here, and then we can go to the visualization options under the pattern section and, for example, change the grid mode to vertical to have this layout. Or we can set it to another mode. Any other mode that we have in mind. So, by using coding, we can enable parametric capabilities. Well, now we've used this module and seen its information, or it can be set to solid color, meaning nothing is displayed, just shows us a 3D object without the texture or schematic appearance. Or it can be set to this mode, and when it's in this mode, it's better to use it on this type of roof. So, we either have a footprint or we have a mass. That is, we have a footprint like this, and we've turned it into a mass. For example, using the push-pull tool, we gave it a height, say 20 meters, as shown here, and we could control its distance from this section. Suppose we raised it up like this. From the perspective of CityEngine, this still isn't a model, because as we said, in CityEngine a model is only created when there is code in the rule file. To turn this into a model, we can use a ready-made module called Building Mass Texture ICE. All you have to do is grab it, drag and drop it, and it will be applied to this, and again, you can control its parameters from this section. For example, you can now set its usage to any mode you like. These are the two modules. The next module is related to plants. Let's assume we have a space. For example, this space. Let's say we have this space. We want to use trees in this space. Well, either we have to write code, or we have to drag and drop the trees. But as we said, dragging and dropping objects is not really the purpose of CityEngine. The purpose is to bring objects into the code and apply that code. Now, here we have a ready-made module called Plants, which has two structures. If we use the plan distributor, meaning we select its first module, it creates this situation for us. In the Inspector section, we can set its mix mode, because this code is written based on the transect theory, that is, a theory that the new urbanists developed in the 1990s. They used a series of codes to say, for example, if your zone is in the central area, it should look like this. The state of its trees. Here, we can enter our information based on different zones. I recommend that when you use this code and this module, you set the trees to zone number 8. Why? Because the trees are more urban and give you a more urban scale. And now, other information. For example, we can double the density from here. You can easily see that the information related to the objects is updated here. That means, as we do this in real time, because it's code-based, every time we update the parameters and press enter, the information is updated instantly. This feature is amazing. Now, the point here is that in this plants section, we can bring in different types of trees or change the representation or display style of the existing trees. For example, if we're working on an urban renewal project, it's better to use the schematic mode. That means we should model the trees in schematic mode. Or for instance, if we're using a lot of trees and our system's performance is dropping, we can switch to the fan mode so that the trees are created using just 4 planes. There's no need to make it heavy and use full models. Or, we can set it to model mode, select realistic, and have the trees in model mode so that when we get closer, we see the actual tree models. You can see that the tree models are fully present. Alright, this is another module that we reviewed together. Here's a golden tip. In traditional tools, if you did something like this, dragging and dropping trees here, and then you enlarge the area where you did this, for example, this circle that's the ground, if you made it bigger using the scale tool, I'm going to enlarge this circle with the scale tool. In traditional tools, if you did this, your trees would either stick out of that area, or when the site got smaller, some of the trees wouldn't fit. But when you do this within a code-based structure, everything becomes interconnected and dynamic. Now, if I come and increase its scale, you can see that the code structure updates the information in real time. This is what we mean by real time. It updates the data instantly. Right now, we've made the site larger. The tree network updated itself, and if we make it smaller again, the same thing will happen. It updates itself again and displays the information and models once more. Well, this is actually a really important point. The main idea is that it no longer matters what shape we have. Whether it's a circle, a square, or a rectangle, it makes no difference to us. Why? Because we've written the code framework and established the main structure of the code, and now, no matter what shape we apply that main structure to, it will be implemented. Because the code structure is parametric and dynamic, and it can adapt itself based on the shape that exists. The next module is in the street. Suppose we've drawn a street. We have this street and we want to model it, but we don't know how to code yet. We haven't learned it yet. We want to do this quickly. All you need to do is select the street you've drawn and choose either the Modern Simple or Modern Standard module from Street. Whichever of these two you want. The complete street module will be provided to you in later parts of the tutorial, and we'll go over it in more detail. But by default, you have these two. You can choose whichever of these two you like. To select, just drag and drop it onto the shape you have. Let's select the shape one more time. Drag and drop it onto the shape we have, and the model will be created for us. That's it. Now, the street model has been created for us, meaning, without us providing any textures or doing anything else, this happened automatically. The next point was that we said the street data is parametric information. For example, if I set this to 12 right now, that's it. All the information is updated. The textures are updated. I don't need to do anything at all. Now, suddenly I realize that my street is 15 meters wide. I type in the number 15. That's all. There's absolutely no need for me to reapply the texture. Why? Because the texture is defined within the code structure, and once it's defined, whether my shape gets a bit bigger or a bit smaller, it doesn't make any difference to the code structure anymore. It automatically adapts itself to the existing shape. Or for example, say I want the sidewalks to go from 3 meters to 5 meters. All I have to do is enter 5 and 5 here, hit enter, and as you can see, it updates itself again. So, this is another module we've used. Now, using these few modules we've learned, we want to model a neighborhood together as a brainstorming session. Let's quickly see how much time this will take us. Using the graph feature where we had smart blocks, we'll take advantage of this capability and implement a brainstorming session. We mentioned that this smart block is dynamic, meaning I can grab the W tool and move any part of it wherever I want. I can do this very easily. With D and G, I remove the grid from the floor and grab this. For the brainstorming, I want this area to expand a bit more structurally from this side. From this side, I use the W tool, and from this side, even more. I even want a bit more from the top section. Then I select the street tool. I'm implementing the brainstorming. I connect this here to increase permeability. I select the street tool. I add a new street to this part, and also here. With the Smart Block tool, I select the area around here. I set this to offset subdivision. We also set this one to offset mode. I want to consider this area as a green space, meaning it should be an open space in this layer right here. So, I set all of this to no subdivision. I set this whole complex to no subdivision, and this one here again to offset mode. And now, with the brainstorming we have for ourselves, we can select these. Well, once we've done this, I can, for example, say that this street here forms the main backbone of my neighborhood. That's why, for example, I can use the lasso selection tool and actually select this street here and set this street to, say, 15 meters. Now, 15 meters is a bit much. For example, I can do this at 12 meters with 5-meter sidewalks, and once I've done that, now I have my block grid here. We've done the parceling here as a brainstorm, and now we have our network. Now we want to use the ready-made modules. We select our entire network. We go to Azraelipe, and from Rules, we choose the street option. I select one of these, the simple one. I drag and drop it onto this. Our street network has been modeled. It's that easy. I disable the street network and turn on the block network. Here, we had an open space, these two. I select them both with Shift. I go to the Plans subfolder and use the Plans Distribute module. Just like that, we set its mix to several. We set its mix to zone number 8. We said, based on the Transk theory, we set it to zone number 8. Very quickly, we were able to model the vegetation there. If we need to control its density, we can also adjust its density from this section. For now, there's no need. Now, for the network related to our lots, we want to select one of them, like this one that has access to the street. From the Select Sim Start section, the lots are selected. This lot does not have access to the street. From the Building subfolder, select Building Front Footprint, since these are footprints and there are no masses anymore. We drag and drop this onto the shapes we had. Just like that, we were able to create a 3D model of a minimal 3D design based on the brainstorming we had in mind, without knowing how to code. Without having to write a single line of code ourselves. That's it, our brainstorm is created, and now we can import this into software like Twinmotion and create an animation from here or use it in our projects. As we explained, this information is parametric. Now, we can change any part of it that we want. For example, I want to quickly set my work to schematic mode. I select one of these. I click on Select Similar File. As we said, we go to the representation mode and set it to schematic facade. Now here we have a minimal schematic modeling work. Now, whichever one we want, we can make changes to it. And as a final and important point, all of this structure here is dynamic. That means if I come here, select this, and use the W tool to drag and drop, nothing will happen to my model because the structure is dynamic. Or if I take this part and drag it over here, again my model will run and I don't need to do anything special. Now, from this section, we can import this modeling into the software in Twinmotion and generate animation from it. So up to this point, we've completed 2 projects. One was from the city of Zurich, and the other was a brainstorm or our ideation session, which we modeled as our mindstorm. We previously mentioned that in order to add animation to these detailed models and further enhance them visually, we specifically utilized the Twinmotion software application. For this part, I got help from my dear friend Mohammed Reza, who handled the Twinmotion section for US and created urban animations from our projects.